Welcome to Pacesetter 11-12. The today important topic is sets. This is the first chapter of the 11th math. The first we will talk about the definition. The theory of the set was first developed by the German mathematician. His name was George Cantor. The George Cantor is the first mathematician who used this theory of the sets. Now we will talk about the definition. The set are used to define the concept of this is the first definition is a concept. What is that concepts? This is concept of a relation. Concepts of a relation. Concept of a relation and relations and functions. Functions. So what we can say? We can say the set theory or the set is a concept define the concept of a relation and the functions. This is the first definition. The second definition we can give what we can give. The set is a well defined collection of the object. What is that? Set is a well defined well defined collection of object. Collection of object. Collection of object. It is a well defined. Well defined means there is always contradictory about that. The well defined means there should be some inherent qualities. There is a some the properties should match to each other. So this is a very important. If it is the things are not well defined. For example, I'll give you. If I say the all the animals of the earth, it is not well defined. There are the millions types of the animals, so it is not well defined. So it is not the set. The set is a well defined collection of object. The third definition we can give. What can be the definition? The set is the synonymous with the words collection. Set is the synonyms with the word collection. The set is the synonyms. Synonyms. Set the synonyms of with the words that words are the collection aggregates aggregates. These are the collection or the aggregate class and comprising of the element. And what is that? Comprises element. Correct? Element. So how the third definition? Set is the synonyms. Synonym. What is the synonym? Synonyms means having the equal meaning. So it can be the words that is the collection and aggregate where it comprises the many elements. Correct? The elements. Correct? The fourth. What is the fourth? The fourth we will see the word I have used the element. Now what is the element? The element is the element you should understand. The element. If we use the element, the objects, and element and the objects, or sometimes we can say the members. These all are same. I can use sometimes the element, sometimes I can say the object, and sometimes I can say the member. These all are the same. Correct? If there is a set, these all are the many objects. These all are the many members. These all are the many elements which are the subset or which are the members of the particular the set. Correct? The fourth, the fifth point we must know. What is that? The mathematician realized to use the some primitive undefined terms like the element. So this is the elements and the set are not the well defined. It is not the well defined. Correct? It is not well defined. So what we realized to use the some primitive. Primitive means primitive meaning of the primitive you should understand, which is not well defined. These element sets are not well defined. Many people, many mathematicians will give the many definition. Correct? So these elements and the set, both are not well defined. There is no standard definition for that. Correct? As per the convenience, as per the requirement, it will keep changing. Correct? This is all about the set. Then, after knowing the definition of the set, we should know the second important thing. There is the basic terms in the set. What are the basic terms we are using in the set? Basic terms. Basic terms. Terms in set. Correct. Basic term in the set. The first, the object, element, and member of the sets are, we know it. The first already we know. What is that? The objects, the elements, and the members. Members all are same. Correct? These all are the same. Okay, we are using as a terms. Normally elements are not dependent. In the normal, you will find in the normal while expressing or writing the set, normally the elements are or the numbers are not repeated. In the roster form, it is not repeated. Means hardly you will get the set like this. If it is the 1, 2, 3 and 4, the another set, if it is written like this, the same set if they are writing, if somebody is writing 1, 2, 3, 3, 4, 4, it doesn't make any differences. Correct? Because there is a repetition of the element. These all are the member, these all are the elements, these all are the objects. Correct? It can be anything. So here we find that if there is a repetition, it doesn't create any sense of that. Correct? It is as good as if I am writing 1, 2, 3, or you are writing the 1, 2, 3, 3, 4, 4. Correct? So it doesn't make the difference. Correct? So the both the sets are the same only. The second we will see the set are denoted by the capital letter. The sets are denoted by capital letter. That is a capital letter. All the sets are like that. The A, B, C, like that. It will be denoted by the capital letter. Correct? The second. The third, the elements of the member are denoted by the small letter. The third, we should know all the small letters like A, B, C, D, etc. These all are used as a elements. They are denoted as a elements, member, or the objects. Correct? Members or the object. Correct? These all are denoted. The small letter denotes the elements, member, or the object. Correct? The fourth point we should know, if A is the element of the set, if A is the element of set A, correct? Set A, correct? A is the element of the set A, and is set belongs to the set A denoted by the. So how to show it? There is an element where the symbols are there. So the A is we can write A is the element of set A. It will be written like this. We will read like this. A is the element of the set A. Okay. So what is that? This is called the epsilon. What is that? This is the epsilon. Correct? Epsilon. This is called the epsilon. Correct? The Greek symbol denotes the phrase belong to. The meaning is it is a Greek word. The Greek word it represents that belong to. So you can say A is the element of the set A, or you can say A belong to set A. Both are correct. Correct. Either you say belong to or you say is the correct. The both is correct. Both are the correct. Now we'll say how the set can be represented, how to express the set. There are two ways of the writing or expressing the set. There are two ways are there by which you can express it. The method of representing. The method of representing representing sets. There are two ways are there by which we can write the sets or the sets can be represented. What are the ways are there? The first is a roster. First is a roster or tabular form. What is that? Roster or tabular form. Correct? Tabular form. Tabular form. You must be aware about the roster. Everywhere in the class you find the teacher roster. You find the monitor roster. The roster you keep getting in the class. So it is a tabular form. Anything is put into the tabular form, we say it is a roster or the tabular form. The second way of the representation is a the set builder form. What is that? Set builder form in which we are using the language. Correct? We are using the language. The first we will explain about the roster or the tabular form. Roster or the tabular form we will use. We will explain it first. What is that? In this form of the representing the set, in the form of representing the set, it is described by the listing the element. We are writing all the elements in between the curly bracket. The all the elements and the members are written in the curly bracket, and it is differentiated by putting the comma in between. Correct? So when we put the comma, it is a distinguished. It is a differentiated within the bracket. The bracket we so call it the braces also. Correct? Within the braces. Correct? So the set, the example, how can you show? Is example set of the vowel numbers. How if the set of vowel, if we have to write the set of vowels, then what will write is equal to A, E, I, O and the U. Correct? This is the set of the vowel. The other example we can say the set of the natural number. The set, another example will give set of natural number. Correct? Natural number. So natural number will start from the 1, the 2, 3, the 4. If there is no limit is given, no limit is given, so we will put the dot dot dot. Okay, so dot 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 indicate means so on. What we call in the set theory, it is a the so on. It is a so on. Correct? Now we will give the few more examples. We will do the we will see the few more examples from your exercise in the roster related to your roster form. We will see the some examples. Correct? The collection of the all even number already we have seen. We have seen that if there is a set, suppose one example we will say if there is a set A, which has got the element that is a 1, 2, 3 and 4. Correct? So we will write the 1 is the element of 1 is the element of A. The 2 is the element of the A. Correct? These all are element of the A. Understood? So the 4 is a element of the A. So these all the members are the elements of the particular the set. Correct? Write the following into the roster form. Yeah. So we will see the next example. The next example is the question is given. Write the following into the roster form. Write into the write into the roster form. If they ask you to change it into the roster form, correct? Now, what is the question they are giving? The collection of the that is a question is given. The F, the F is the set of the all letters in the word. In the word particular, they are taken. Suppose the some word they have taken. Some word I am taking. the set, it is a set which f is equal to set the set of all the numbers, all the set of all the letters of all the letters. The letter is suppose B-E-T, bet, correct? The letter of the bet. So here what we can say, the F is equal to the set will be, whose elements will be B, E and T. These all are the elements of the set, correct? Curly bracket will be there, correct? So this is the way you can write into the roster form. Write the following set in the set builder form, correct? So these are the way you can write into the different way. The examples of the other example you can see. Suppose somebody says, right, the set one set B is there. The set B, in that we find that it is a numbers. The numbers, that is a natural number. The natural numbers less than less than less than 10, then we can write it to the roster form. How we can write to the roster form? We write that B is a set which contains the member starting from 1, 2, 3, 4, 5, 6, 7, 8 and the 9, because natural number is a less than 10. The less than 10 will be 9 and below, correct? And these all are the elements of the B. These all are the element of the, these all are the element of B, set B, correct? So the 4 is also element of the B. The 9 is also the element of the B, correct? This is the way we can write it into the roster form, correct? So I think you are aware of that, correct? So next is a set builder form. What is the another one? It is a set builder form. In the set builder form, we are using the language. The next is a set builder form. Set builder the form. Set builder form. The set builder form is described by a characterizing the property. We are using the like a px and all. We are using the small x to represent its element. Normal cases we are using the x. You can use the any other element, any other alphabet also. So we are using the x, y, anything you can take it. But normal cases we are using the x as an element to represent that. The px of is element x. In such cases, set is described by. So the how the set will be described here. They will write like this. What they will write? There is a the x is that the px, the px where the holds, correct? The holds, or we can write x x x, we can write the stroke the px, the px the holds, correct? The holds, correct? The which is read as, इसको पढ़ेंगे कैसे? We can read it, how to read, as the set of the all x's that the px hold. The px normally we understand it is a polynomial x. The px can be, it can have the many things. The px we will say the how to read it. It's a read as it is set of all x. It is a set of all x which holds, which follows, which represents the px, correct? The px, the symbol we are using the two symbol. The one is like this or the other is like this. There are two symbols we are using. Is read as the such that, is a such that, we will say for that such that means how we say, is a set which element is a where x, and x is a such that is a px holds, correct? So we can use the such that, or we can use the this the two bracket is called the colon. What is that? The colon. In both the cases we can say the such that, correct? So there are the other example. List all the elements of the following sets. So we'll say the other example. The example we are taking. Suppose if it is given, list all the elements. List all the elements. Elements elements of the following set. Of the following set. Correct? The following set. How we will write it? We will write that the f is a set is equal to the x. X is a x such that x, where the x is such that x is a consonant. That is a consonant in the consonant in the English alphabet. In the English English alphabet. Correct? Alphabet. Correct? Alphabet. It's a English alphabet. Correct? This is the way you will write the anything. List all the elements of the following set. The following set is a basically it is a set of consonant in alphabet. Correct? To be written into the this form, the builder form. How we will write? We will write the x. The x is the element such that, or whereas the x is a consonant in the English alphabet. Correct? This is the way you can write into the roster form. Correct? Now we will say the different types of the set. I think we are aware. The how can you? So always with the a small letter of the x, you represent the only one element, and where you can write in the different ways the how the x can be. This is the one of the way of the writing. There is another way we can write x is equal to if it is a suppose if I have to show the uh, vowels. If we have to show the vowels in this form, what we will write? The x is there, whereas the x is what we can say? X is the vowel of the English alphabet. Alphabet. Correct? The another one more example I'll tell you how to do it. You can write it also. Suppose you have given the example the a is a one where you have to write that its members are suppose the 1 2 3 and the 4, and you have to write into the builder form. Then what you will write? You will write that a is equal to in the set of the x, whereas x क्या है? The x you will find it, you put the x. X is less than and equal to is equal to the 1. Correct? Less than and equal to the 1. Correct? Equal to 1, and it's equal to 1, and is a less than and equal to the 4. Correct? So these all the terms will be coming. Correct? So this is the one of the way also you can put it. That indicates that there is a number which is a start from 1 and end with the 4, and the both the 1 and 4 are included. That time you have to put the equal to. Suppose the if it is not to be included, then we will remove the is equal to. This is the way by which you can represent the set builder form. The next is the type of the set. So here we will see the empty set. The first is a empty set. Empty set. The empty set or the word. This empty set can be set the null set. It can be set the void set. What is that? The void set. These all are same. Correct? These all are same. The empty set, null set, and the void set. These all the sets are similar. All it's having only one set having the three names. Remember, when you have the set where you find that there is a no member. For example, if I say that A is a set, A is the set where I am writing the man, with with three hands. Three hands. You know the man with three hands. Man with three hands will not be there. Man has got the only two hands. The man with three hands will not be there. Means you find that there will be no elements. You cannot find the man with three hands. So the no element is there. Then you find that if there is a no element, then we say it is a phi. Correct? Phi. The phi denotes that there is a no element. Correct? No element. Correct? Understood? That it has no element and it is denoted by the phi. In the roster method, phi is denoted by in the if this is the tabular form. This is the tabular form. If you represent in the roster form, this is the roster form or the tabular form. If you want to put it into the builder form, then this will be indicated by the phi is indicated in the roster, and in this you will be denoting by like this. Correct? Nothing you are writing in between. This is said to be the empty or the null set. In the set builder you can write in the another. How you can write this? They can write that a is equal to, this is also one example, x such that x square is equal to minus 2 is equal to the 0, and x is the natural number, and we say that x is a natural number, where we say the x square minus 2 is equal to the 0, x square equals 0, and we say that it is a natural number, and x is a natural number. X is a natural number. X is a natural number. X square, the plus x, if I say x square the plus 2 is equal to the 0, and we say the x is the natural number. The natural number, as you know, it starts from the 1, 2, 3 and 4, or here I am giving x square is equal x square plus 2 is equal to 0. So what will happen? The x square plus 2 is equal to 0. The x square is equal to minus 2. So x is equal to under root minus 2. Understood? So this whole is not possible. It is not a natural number. So we say that it is a empty set. Correct? Understood? So this is a empty set. Now we'll see the another set. The another set is a singleton set. What is that? Singleton set. Single, SINGLE, singleton set. Correct? Singleton set. What is the singleton set? The singleton set is one where you find there is a only one element is there. For example, M is a set. M is a set where you find that there is a only the two. Correct? Only one element is there. That is a two. Correct? The set consists a single element. Here 2 is a only one element. Where you find that single element is there, we say that set is a singleton set. Correct? The singleton set. Understood? Okay. So how this is the roster form you can write it. Correct? In the another way of writing, you will find that B is a correct the x such that x is the element of the n. If I write x is the element of the natural number, correct? Natural number and natural number, correct? X is the element of the natural number, and we write that x square is equal to the 9. X square is equal to the 9. You know that if I say the x square is equal to 9, the x square is equal to 9, the x will be always equal to plus minus 3 ka whole square. So the x will be always plus 3 and the minus 3. Understood? The x square, the x will be plus 3, x is equal to plus 3 and minus 3. Whereas we have seen that x is the element of the natural number. So it is a natural number. The natural number which is there, this is the only natural number. So what you are getting? The only plus 3 is a natural number. You got the only one element, that is a plus 3, so we say it is a singleton set. Understood? The example, the both the way I have explained how to represent, correct, singleton set by the roster and the builder form, correct. I think you have understood. There are two terms are there, the finite and the infinite set. The finite set, and another is a infinite set. Infinite set. The finite set, suppose if I say the counting number less than 10, the less than 10 means you understood the number start from the 1 to 9, or if I say the number is up to 10, this means also we understand that it's a number start from 1 and end with the 10 because it is up to 10. Understood? So this is a finite, means finite means the number which is counted, which you can count it. So that type of the set is a finite set. But if I say it is a set, where there is a number of the stars, we can't count it. So it becomes the infinite set where there is no accountability. If I say gentleman, एक लड़का सामने बैठा है, हेलो कुमार, यू आर द बॉय, if somebody is asking तुम्हारे सर में बाल कितने हैं, तो ये बाल कितने हैं, बाल तो है, कितने हैं काउंट नहीं कर सकते, so that become the infinite set. Understood? So how to go ahead? Now we'll see. A set is called a finite set if it is a either word set or its elements can be listed. Okay, so it can be either it is a word set. Word set means it is having the only nil elements, or nil is also that, zero is also no element, also zero is a element, correct. In the finite, if there is a no element, this is called the word set. This is also said to be the finite set. In the infinite set, what we say, where the elements cannot be listed by the natural number. If you can't, first one by one we will say what are the points are there. So if the set is a word set, correct? If it is a word set, or if it is a word set, or its element can be, or the elements can be listed. Can be listed means you can write by using the counting number. You can denote it. Then we say it is a finite set. The example I will give you. It can be, the elements can be listed by using natural number. I think you are aware about the natural number, or you can say the counting number, correct? Counting number. How can you, the example will see it. The first will give the example. What is the set of the even natural number less than 100? The one set is there, set of natural number, that is a natural number less than 100, correct? Less than 100, we can write like this. We can write the A is the set in the tabular form. Start with 1, 2, 3, 4 up to the 100, correct? Less than 100 means it is a 99, correct? Less than 100 means it is a 99. The other of writing the roster, other way of the writing the roster is the A is a set where we say X is element such that the X is a element of the natural number which is less than 100, correct? This is said to be the roster form, correct? This is the roster way of the writing, correct? This is all about the finite set. Now we will see the infinite set, whose elements cannot be listed. The first point, the element cannot be listed, by using what is that, by using the natural number, correct? Natural number हम जिसको count नहीं कर सकते, that is called the infinite number, correct? The example, set of all lines in the planes, correct? अगर मैं कहूँ the lines, it is a set of lines in a plane. इन ए प्लेन, एक प्लेन में कितने लाइन खींच सकते हो? ए प्लेन है, देखो ये सब क्या कर रहा हूं मैं, लाइन खींच रहा हूं। कितने लाइन हो सकते हैं? इनफिनिटिव, करेक्ट। सो इट विल बी सेड दैट इन फाइनाइट सेट, how to write into the roster form? The roster form you must practice to write the roster form. If I say A is the set of the lines in the plane, how will write? It is the set X, and X it is a set of the X where we find that the X is the, that we will write the X is the element of the real number. If we say the X is the set of the real number such that the 0 is X is greater than 0 and the less than the 1. This is the way also we can write it, correct? This is the way of writing the into the builder form. So this is all about the finite and the infinite set, correct? I think we all are familiar with the finite. Now with the finite and the infinite the set. The next we will see the equal set. Next is a equal set. Equal set. We have already seen in the trigonometry or many other places what is the equal. When you say the equal, the everything has to be the equal. The particular in the set theory, the two sets are equal. If the every element or the each element of the one set is present in the other set, and if the other set all element of the members are present in the first set, then we say it is a equal set, correct? So if we take the example, suppose A is there. A is the set which has got the elements of 1, 2, 3 and 4, correct? The B is a set. B is a set which has got the element of the 1, 2, 4, 5, correct? And C is the set got the 2, 1, 3, 4, correct? So you find that what is there? You find that A and B are not equal because all the members of the A, 1, 2, 3, 4, 1 is there, 2 is there, the 4 is there, 3 is not there, and 5 is additional. All the members are not present in the B, and B all the members are not present in the A, correct? Not present. So the A is not, set A is not equal to set B, correct? However, the set A, you find that 1 is there, the 1 is there, the 2 is there, the 2 is there, the third is there, the third is there, and the fourth is there, and the fourth is there. The all the members are there in the C, irrespective of their sequence. Sequence doesn't create any impact on the set. So we will say the A is equal to set C. Understood? So this is the equal set. I think you have understood, correct? The equal set once more I revised. The all the member of the A is present in the B, and all the member of the B present in the A. We say that it is a equal set. The next set we will see. What is the next set? The next set we will see is a equivalent set. The equivalent set. Equivalent set. Equivalent set. We already know, familiar with the word equivalent. The equivalent, I said already the fraction you see 1 by 2 multiplied by 2, 2, it become the 2 by 4. Multiplied by the again 2, it become the 4 by 8. These all are equivalent, correct? The equivalent, correct? So here, what is the equivalent set? The equivalent set is every element the one equivalent set. The two finite set A and B are the equivalent set if there the cardinal numbers are same. Cardinal numbers, n is a number which in the alphabet or the digit. So the first condition, this will not be happen. The must be क्या होना चाहिए? A must be finite set जिसको हम फाइनाइट सेट क्या होना चाहिए, मस्ट बी फाइनाइट सेट होना चाहिए, करेक्ट है। इक्विवेलेंट सेट के लिए क्या होना चाहिए, काउंटिंग वाला होना चाहिए, चाहे वो नल सेट ही क्यों ना हो, बट देयर मस्ट बी द अकाउंटिंग एलिमेंट, वेदर इट इज ए अल्फाबेट or the digit must be accounted, you should be able to count, correct, understood. So this is the equivalent set, the first. The second point of the equivalent, what is the equivalent, the number of the elements, number of element, what you say, it's a number of elements or the member, whatever say members, it can be in the form of, in the form of क्या हो सकता है, it can be formed in the alphabet, alphabet or the digits, correct, किसी भी form में हो, the number of the elements in both set must be equal, must be equal, correct. If the number, suppose if I have the set where there are two members are there, and in the set B there are the again the two members are there, correct, then we will say the both are the equivalent set, correct. Okay, the equivalent set, the example we will see, if there is a set whose elements are 1 2 and 3, correct. The another set we have the B whose set has got the element A, B and the C, correct. The number of elements कितना है, number of element इसमें कितने हैं, element 3, number of element इसमें कितने हैं, number of element is 3. So the both are the equivalent set. How to write it, equivalent set, we will say the number of A is equal to the number of B, so they are the equivalent set, understood. They are the equivalent because both have got the 3 number of the element. Remember, both are the equivalent set, but they are not equal set, they are not equal set, correct, equal set. Why they are not equal set, because the element of the A is not present in the B and the element of the B is not present in the A, so we say it is not a equal set, correct. The equivalent set is different from the equal set, correct. Now we will see the very important and the interesting topic is a subset. It's a subset, correct. It is a subset. What is a subset? The subset, to define a subset, if every element of the set A, suppose we will say the subset. So what is subset? If every element of the set A is also the element of the set B, the A is the subset of the B. Suppose if I say A is the set whose elements are, suppose A, B, C, correct? C, and the B is another set which is the larger than the A, having the element A, B, C, D, E and F, correct? So we find that all the elements of the A are present in the B, correct? So it becomes that A is the subset of the B, correct? A is present, A is present, B is present, B is present, and the C is present and C is present. So the A is the subset of the B. This can be denoted by like this also. A is a subset of the B, correct? The both the symbols are correct. Both way you can write it. Understood? So A is the same. But remember, the B is not the subset of the A. B is not the subset of A. Why? Because the element of the B, all the element of the B is not present in the A. The D, E, F element of the B is not present in the A. So we say it is not the subset of the A. The B is not the subset of the A. So there are many things we should understand. Okay, so we have seen that So all the elements of the B, particular the D, E, F is not present in the A. So we say the B is not the subset of the A. Remember here that one more important thing, sir. Here the B is a one which is having the all the element. The B is having all the element, having all the element, all the element, all the element of A, correct? A. So the B becomes the superset. So we can say B is the superset. Superset. B is the superset for set B, correct? The B is the superset for set A, correct? The B is the superset. This can be denoted by the B is the superset of the A, correct? B is the superset of the A. The superset means the superset you should understand. Suppose your father is a set in which you have the 3 4 children. So all the 3 4 children are the subset of your father, of your parent, and this since all the everything is all the characters of yours is in the father, but there beside that there are many extra character is found in your father. So father become the superset for your all the children, correct? So father is a superset for the children. Understood the superset. Next, the what are the condition and what can be that the superset. The every set is a subset of the itself. Now we will say the what are the condition and which are expected to be the subset. You understood? If I take the example A has got the element of A, B, C, correct? C. Then what can be the subset of that? The one subset can be the A, correct? Is a one subset, correct? The one is a subset. The another can be the B. The next can be the C. The next can be the, you can find that it is a B, correct? The another can be the AC. The next can be the B and C. How many you got it? 1 2 3 4 5 and the 6. Next what can be there? The next can be the number itself. The set itself is a subset of itself. So the ABC, correct? And we can find that next will be the one will be the empty. 1 2 3 4 5 6 7 and 8. So there could be the 8, means that indicates that it is based on the formula. What is the formula to find out the number of the set is equal to 2 to the power n, correct? Where the n is the element, n is the number of element, correct? Number of element or the member, whatever you say. So here you find the 1 2 and 3 are there. So we will find the 2 to the power 3, it becomes the 8. We can find the 1 2 3 4 5 6 7 and 8. With this formula you can find out the how many the subset can be there, correct? The subset can be there. This all is based on, so how we can put it the language. We have seen that the number itself, the element itself or set itself is a subset. The first of what we like, the every set is the subset of itself, correct? Itself कोई भी सेट है वो अपने आप में एक सबसेट है, करेक्ट? सो वी हाउ वी कैन से ए इज द सबसेट ऑफ ए, करेक्ट? ए जो है सबसेट किसका हो गया? ए का हो गया. नेक्स्ट नील, नल बोलते हैं ना, नल और द इम्प्टी इज द सबसेट ऑफ एवरी सेट. कोई भी सेट ले लो, उसका सबसेट जो है एक तो नल होगा ही, इम्प्टी सेट होगा ही. दो मिल गया. द तीसरा थर्ड द प्रॉपर्टी वी शुड नो व्हाट इज दैट? द टोटल नंबर ऑफ द सबसेट. Total number of number of subset. The subset is equal to 2 to the power n, where n is the number of what you want to say member. With this formula you can very well found out the subset, correct? The subset, you can say the subset of the set R of the real number. If I say the n, suppose n is a natural number, the natural number is a subset of, I can say, is a real number. Am I right? Natural number is a subset of the real number, because real number contains the natural number, whole number, correct? In other word also I can say the real number is the superset for the natural number. The natural number is 1, 2, 3, and real number is keeping other than this integers, whole number, this all are there. So the real number is a main having the more element with respect to the n. So the n is a R is said to be the superset for the natural number of the set which contains the natural number, correct? Okay, so there are few terms we are using the short form. So we must know what is that n. The n stand for the natural number. There should not be doubt. If it is written n, you should understand they are talking about the natural number, correct? The next is a z. The z is a set of, it is a set of integers, correct? Z is a set of integers. The integers means it can be the positive as well as the negative integers. The q, if they have written the q, then you should understand the q is a the set of the rational number. It is a set of a rational number, correct? A rational number, correct? Natural number set, correct? The q is a natural number, sorry, the set of the rational number, correct? Then we will see the t, the set of the irrational number. The t is a set of irrational number. Irrational the number. It is a set of the irrational number. R is a set of real number, correct? The real number, the set of the real number. So by seeing this many, the short form of the numbers, we can write that n is the subset of z, correct? Z is the subset of q. The q is the subset of r, and the t is the subset of the r, and n is not the subset of, we can say it is not the subset of the t. This all you should understand, correct? Now we will see the other set. The next set is a proper set. The proper set and the power set, the two more we are defining. The first is a the proper set. What is the proper set? Proper set. What is proper set? The set A and B. The A is a subset, but the B is a not the subset of that. Correct? The power here we will say proper set. No, it's a proper subset. What is the proper subset? The proper subset remains the same. I have explained you. Suppose the A is having the 1, 2, and 3, and the B is having the member is the 1, 2, 3, and the 4. Since all the members are there in the B, so we will see the A is the proper subset of the B. Correct? A is the proper subset. The proper subset, where the you find that, but B is not the subset, proper subset of the A. Correct? Not the proper subset of the B. This is the same. The next is the power set. Next is a power set. Power set. The power set. The power set. The collection of all subset is a set to be the power set. Correct? The collection of all the set, all the subset. Collection of power set क्या है? It is a collection of all the सबसेट जितने सबसेट बन सकते हैं उसके कलेक्शन को हम क्या बोलेंगे? द पावर. इट विल बी डिनोटेड बाय, सपोज ए सेट है तो इसको पी ए से डिनोट करेंगे. करेक्ट है? द पावर ऑफ द सेट ए. करेक्ट है? द कलेक्शन ऑफ ऑल सेट. सपोज द एग्जांपल आई एम गिविंग, the A is a given where the example is the 1, 2, 3 is there. The how many subset can be formed? You can say the one subset. कितने subset होंगे? The subset, as you know, the 3 is there. So the 3 means the 8 subset will be there. What are the subset will be there? Subsets कितने होंगे? The one will be the empty. Correct? The another will be the 1. Next will be the 2. Next will be the 3. Next will be the 1 and 2. The 1 and 3. Next will be the 2 and 3. Correct? And last will be the 1, 2 and the 3. Total we got 1, 2, 3, 4, 5, 6, 7 and 8. Remember the 2 and 3 and 3 and 2. Sequence is changed. There is no change. It remains the set only. Correct? So we will write the power of set A. The power of set A will be like that. The 5. Correct? This is the element. Correct? Here, this is the another 1, comma, is a 2, comma, is a 3, is a 1 and 2, is a 1 and 3, is a 2 and 3, and next is a 1, 2 and 3. Correct? So this becomes the power of the set. This is called the power of the set. Now we will see the another, that is the close interval as a subset R. Next is a interval as a subset R. Okay. Next is the interval as subset R. The interval as subset R. Interval as subset R. There are basic things we should understand. Suppose if we have to denote that A and B, the A and B, then how we will draw it? If we are drawing like this, this line is there, all the elements are falling in this in between line, and this is, then we say that this is the both the elements are exclusive. Both elements exclusive means both are not accounted. In this case, you should understand the both the numbers are not accounted. Correct? So we will call it the open. This is what we will open interval. What we call interval. This is called the open interval, in which the both the elements are there. Suppose if I say 5 and 10, but 5 and 10 elements are not included, then we will say it is an open interval where the digit elements will be starting from 6 to 9. So it is called the open interval and will be denoted by, suppose, the A and B. Correct? Yes, will be like that. Correct? Both are not included. Correct? Open interval. Now we will see the close interval. If the sign is a symbol is like this, the both will be equal size. Correct? Both will be of equal size and it is a completely filled, then this will be called the closed interval. क्या है? A closed interval. In the closed interval, how we will do it? The closed interval, you will find that it is denoted by like this, A and B. So this symbol indicates that the both the numbers are included. Both numbers are included. Correct? Included. If you get in the number line like this, you should understand. So suppose if it is a 2, 3, 4, 5, 2 and 5 both are included, then we say it is the close interval. Then comes the semi-close interval. The next is a semi-close interval. In this interval, we find that one is a close, another is a open. Correct? Then we say it is a semi-close interval. Semi-close interval. Correct? Interval. Semi-close interval. In that, what the symbol will be like this. This A is a close, but the B is a open. B is a not included. So the semi-close interval. This is a semi-close interval. The next is a semi-open interval. What is that? First is a open, and then we find that it is a close. Correct? So it is a, what we'll say, the semi-open interval. What is that? Semi interval. Interval. The semi-open interval, in that the where open is there, you will put the small bracket like that. The A is a open, correct? And B is a close. Can you see that this is the A, this is the B. A is open and B is closed. So it is called the semi-open interval, correct? The semi-open, semi-close, these are the different types of the intervals are there, correct? Now, here's the set. These next topic we will see about the notation provides an alternate way of the designating the subset of the set are and all real numbers is a the set example the interval. For example, interval that is a 0 and the infinitive denote that set R1 are the all negative real numbers and the interval sets of that, correct? So here we will see the next is a universal set. Universal set. The universal set, what is that? The universal, the set which contains all set under the consideration. The all the sets there are, suppose the example I'll say, suppose if I take the A is a set where the 1 2 3 4 5 6 7 8 9 and the 10 are there. I am taking the B as a member, correct? B is another set which contains the 1 3 5 7 and the 9. This is containing the all the odd number. The C is another set which I am taking. It is the 2, 4, 6, 8 and 10. Correct? So can you see A is a universal which you club or add the A and A, B and C. When you add it, all the elements of the B is present in the A. All the element of the C is present in the A. So in that case, we say that A is a universal set. What we say? A is a universal set of the B and C. Correct? It's a the in the so the universal set will have the many sets. The many sets are there coming out of that. The example of more example I'll see. The what example see? The on X on xy plane. We have the xy plane in the two dimension. In the two dimension. In the two dimension, you have the x and the y plane. Correct? The all set under the you have the two dimension. The set of all points. So what will be the set of all points? Set of all points within this xy plane. Correct? This will become the universal because in the xy plane, if you have the x and y plane, correct? This is x and this is the x dash and the y dash, correct? This is origin. So then in the xy plane, all the points are coming. The whatever the points are coming, these all points are coming into the one of the plane, that is the xy plane, that can have the many. So this is said to be the universal, the set of the all the points in the xy. The other example we can say, the other example is a second example, the n, the set of the natural number, correct? Natural number, correct? So natural number It starts from 1, 2, 3, 4, goes to the infinite, correct? So it's a infinite, but it is said to be the universal set because it contains the many set out of that, correct? So this is all about the universal set. The next is a Venn diagram. The Venn diagram or Venn Euler diagram. The both are said. Venn Euler diagram. Venn is a Venn John John Venn and brought into the this word Euler, Euler, Euler the diagram. Correct. Venn Euler the diagram. Okay, so the Swiss mathematician, the Euler was the first. We started using the set theory. The set first of all was used by the Euler. The Euler is a Swiss mathematician. Later on, the when was the British mathematician who started using of that in the practical form, in the practice, who brought it to the practice, who give it add, who has given in the more and more utilization of the set of the theory was the Mr. Venn, the one of the mathematician from the Britain. So that has become the Venn Euler diagram. In this diagram, if we take the U as a universal set, U if you take the universal set, if we have the three different diagram, I will draw it. Suppose this is the universal set, correct? This is the universal set in which the many elements are there. I will talk about the two elements. I will take the one of the elements. This is a bigger element I am taking, having the much more number. If I say this is the B, a small I am taking, this I am taking as the A. So there are two elements are there, A and the B. But by seeing this, we can say in the universal set U, the A is coming within the B. All the elements of the A are present into the B. So we will say A is the subset of the B. Correct? In the second, we will see that this is the universal set, correct? In that we find that there is a small is a and the bigger is a B, having the more element, correct? So this is the A and this is the B. So we can see that this is the B and this is the A. So you can find that it is A union B, correct? A union B. A union B means the both are combined. Suppose if I give the example, A is equal to the 1, 2 and 3 is there, and the B is equal to, suppose, the 2, 3 and the 4 is there. The A union B, you should understand, it indicates that you take the common in that. The 1 is there, the 2 is there, and 3 is there, and the 4 is there. So the A union B is there. The out of 2, the common one, you take it at first. Additional whatever is there, you put it. It becomes the A union the B. Correct? You understood? The here. Remember, A set is not equal to the B because all the members of the A is not present in the B, and all the elements of the B is not present in the A. Hence, A set is not equal to the set B. The third we will say, we are taking the one of the universal set, the U, in which we find that here is a B and here is a, correct? A and B is there. The both are separated, correct? Both are separate. So what do we find? We find that is called the intersection. The intersection A union A intersection the B. The A intersection B means in that two set, what is a common? The what is a common? Common, you find that nothing is a common. Example I will give. The A is a set where the 1, 2 and 3 is there. The B is another set which is 4, 5 and 6 is there. So what is a common in that? The intersection means comma. The what is a common in that? Nothing is common, no element. It is a phi. It is a null. It is a disjoint. What we call the disjoint set. What is called disjoint set? Disjoint set, null set, the void set. Correct? These all are the different meanings of there. Correct? The union of the set. So we'll see the few more examples. Correct? Few more examples we will see and we will clarify. Then our doubt will be the clear. Correct? The next we are seeing the union of the set. Suppose the union of the sets, correct? Sets. Let A, let A and the B be the two sets, correct? The two set A and B are two sets, correct? Two sets are there, two sets. Suppose the A is equal to 1 to 3, I am taking 1 to 3, and the B I am taking B is equal to B is another set which I am taking the 1 1. This is a 1 1, the 2 3 4 and the 5 I am taking, correct? I have taken this much. The what will be there? The we find that A union B. The A union B will be equal to A union B will be 1 is there, 1 is there. You take it the 1, correct? You got it? The 2 is here, the 2 is here. You write the 2. 3 is here, 3 is here, correct? So 3 you write it. Additional, what is there? The 4 and 5. 1 you have taken is over, not to be repeated. So you will write the 4 and 5. So this become the A union B. Union means जोड़ना. Union means जोड़ना. Intersection means दोनों में जो common होगा, correct? So that should be the understood, correct? How you can write it in the other way? You can write that A union B is a X such that the X is the element of the A or X is the element of the B. This is the way of the writing the building block, correct? That way also you can write. The other way also you can write it. The other way also in the building block write it. A union B is equal to where the X is such that it's a 1 which is equal to and less than the X, where the X is equal to and less than the 5, correct? You understood? So that is the also way you can write it, correct? Next, another way of writing is also there of the building block. How you can write it? The A union B you can write is X such that X is the natural number less than natural number less than and equal to the 5, correct? This is all the three ways are there by which you can write into the tabular into the roster form, correct? Now we will see the something the properties of the operation of the union. The properties. Now we will see the properties of the operation of the unions, correct? In that once more I will repeat. If you take the A is a set where the elements are 1 to 3, the B is a set where the elements are 1 2 3 and the 4 and 5. So in the Venn diagram we can show it like this, correct? In the inversal it's a and B, it's a union. Union means you should understand. You should understand the 1 2 3 is a common. 1 2 3 is a common, correct? Of the A and the B, and the 4 and 5 is a in addition of the common. In the Venn diagram that we will show like this. Now we will see the properties of the properties of operation of the unions. The first property, what is that? The A union B is equal to the B union A, correct? B union A is a, as we know it, it is a commutative law, correct? Commutative law. As per the commutative law, you know it, the A plus B is equal to the B plus A. So here also it follows the commutative. A union B is equal to the B union the A. The second law, the A in the bracket A union B, the union C is also equal to the A union B union C. Correct? B union the C. This follow the associative law. Associative law. Correct? The law of the associative. When there is a change in the bracket, it was A union B. In the bracket, it has come after is equal to B union the C. So it follow the associative law. The rule number 3. So what is the 3? The A union phi. The phi means not having any elements, but phi is the subset. The A union phi is always is equal to the A only, because none of the element is going to be added. So what we call that is the law of identity. Identity element. Correct? Law of the identity element. The phi is the identity. So what we say? The phi is the identity of you. Correct? The phi is the identity of you. The rule number 4. Rule number 4 said the A union A will be always equal to the A. That is called the idempotent, the potent law. Independent. क्या बोलेंगे? Idempotent. What is that? Idempotent law. The potent law. Correct? When the both are equal, the result will be always equal. The fifth is a suppose there is a one universal, correct, set, and the union is a the A, then it will be the universal only. The universal is a large and the A is the with respect to the universal is a smaller. So the result will be universal. That is called the law of universal, law of U or the universal, whatever you say. Correct? These are the 5 rules are there. Correct? We should know this rule. Now we will see. We will see the intersection of the sets. How the intersections are there. Intersection. Already we know that in the intersection we are taking the common one. Correct? The intersection. Intersection of sets. We have seen in the union that both are combining. In the intersection, what will be there? Here, in this case, if you have the universal set and A is like this and the B is like this, A and B, this all the in between whatever is there, that is called the A intersection the B. Correct? The A intersection B will be the common of the both the set. Correct? The A intersection B will be the common. Suppose example I am giving. The A is equal to, suppose I say 2, 4 and the 6, and the B is the other set where we have the 6, 8 and the 10. Correct? So in the universal, the A universal, the B, A universal B will be only, you find out what is the common. A intersection the B will be is equal to the common. You find that 2 is there, 2 is not there, 4 is there, 4 is not there, the 6 is there here and 6 is also. The 6 is the only the A intersection B. The whichever is a common in between the two set, that is called the intersection the set. Understood? It can be the one, it can be the many, it can be the anything. Correct? So the another example you can see. The one more example I am giving. The 4 are there, correct, and the B is another set where you have the element 2 and the 4, then A intersection the B will be equal to the 2 and the 4. It is also 2 and the 4, so we can say it is also called, what we call it, the A, the intersection of the B. So what we call A is a intersection of the B. This short form you can say the A intersection B. Correct? The A intersection B we call it. How to represent in the other format? How can we write it? We know that the A is the A union the B can be written into the roster into the builder form, that is the x. X is the X is the element. The X is a such that is a element of the A, and X is the element of the B. Means the X is the element, that is the 2 4 which is common in the both. So we will say the X is the element of the A and the X is the element of the B. It means the both are the common of the set A and B. So we say the A intersection the B. Remember, the A intersection the B is always equal to the A, correct? Because A is a larger one, correct? Larger one. The A is A will be also the subset of the A will be subset of the B. No, no, no. Here we will see that the B, all the elements of the B is found in the A. So we will say the B is a subset of the A, correct? And we will say the if the A union the A intersection B, the A intersection the B, correct? A intersection it will be equal to the B here. The B is a subset of the A, correct? Okay, this is all about that. Now we will see the properties of the operation of the intersection, correct? The properties of the operation of intersection. Properties properties of operation of intersection. This you should remember the points. The first point is like this: the A intersection B will be always equal to the B intersection the A, correct? B intersection A. This follows the rule of the commutative, correct? Commutative rule, correct? It follows the commutative rule. The second already we see the A intersection B intersection the C is equal to the A intersection the B intersection the C. This is following the associative associative law, correct? Associative law, correct? Commutative law, correct? This is commutative law. The third is the phi. This is null. The phi intersection A will be always equal to the phi, because they are not having the any element, or A is having element. There the common or the intersection will be only nil only, because nothing will be the common in that. So you find that this is a law cell, and the intersection the A is there, then it will be equal to the A only, the smaller one will be there. So that's called the law of phi and the U, correct? U and A you are taking, the universal is the bigger and the A is a smaller. So the A will be the smaller one, which is the intersection. The common will be taken. So law of phi or the law of the universal will say it, correct? Understood? Now we will say the A is a one set, another is a, then is a result will be A, and this law is called the idempotent potent law, correct? Idempotent law. And the fifth is A intersection the B union C will be equal to is A intersection B union A intersection C. This is called the, it follow the distributive law. It follows the distributive law. Correct? Now is a next. Next we will see the disjoint set. What is the disjoint set? Disjoint set. Now we will see what is a disjoint set. Disjoint. Disjoint the set. The disjoint set. If A and B are the two sets, if A and B, suppose if A and B are two sets, What is that? Two sets are there. Two sets are there. And you find that condition A intersection the B is equal to the 5. There is a no member, the nil, the null set, void set, whatever set. Then if another condition, the if A is a intersection of B is not equal to 0, then it will be intersecting or overlapping set. Overlapping set. Correct? It will be the overlapping or the intersecting set. Now next is a difference set. Different of the different set. It's a very simple different set. Difference of set. What is the difference of the set? The difference, suppose the A is equal to, I take it, the 1, 2, 3, 4, 5 and the 6 is there. The B I am taking is the 2, 4, 6 and 8 is there. The difference, what is the difference? The A minus B, the whatever is there in the A, you deduct it. The A minus B, A has got the 1, 2, 3, 4, 5. The 2 is there, 2 you remove it. The 4 is there, 4 you remove it. The 6 is there, 6 you remove it. Correct? So whatever is there, you are removing it. So you are getting the 1, 3 and the 5. So A minus B is a set. This has got the 1, 3 and the 5. So the B can have the more or less, doesn't make any difference. The A minus the B, whatever the is the B, that must be deducted, reduced or the subtracted from the A. It becomes the A minus B. Remember the B minus A, when we find out the B become the main. So B, whatever the elements are there, that we will deduct it from the A. Then we find that only the leftover is a only the 8. Correct? So it becomes the, can you find that A minus B means all the elements of the A 1, 2, 3, 4 minus the 2, 4, 6, 8 left over you are writing. B minus 8, you take the B and the minus you do it. Correct? Minus you do it. So whatever is there, you are deducting, you are getting 8 as the extra. So that is the B minus S. So here you find that A minus B is not equal to the B minus A. Correct? That you understood. The system differences, the symmetrical differences of the two sets. Now what is the symmetrical differences between the two sets? If A and B be the two sets, then the symmetrical differences of the set A and B is the set of A minus B is union to the B minus. I'll tell you, I'll explain you. Now is a, please have patience, hardly it will take 10 minutes more. Correct? Please bear with me. Symmetrical differences of the two set. This is a symmetrical differences, difference of two set. Correct? What is that? If there are the two set, if you take A and B are two set, correct? The two sets are there, correct? Then the symmetrical difference of the set A and B is A minus B. So what is that? The symmetrical difference. The symmetric difference. What will be the symmetric difference of sets A? Set A and B. What is the symmetric difference between the A and B? So simply that is equal to A minus B union. If you do it, the B minus A. If you do it, then what becomes? And is so this will be denoted by the symbol. What is the denoted by the symbol? It is a symbol. So this symbol is denoted like this. So that will be denoted by A is a symmetric difference of the B. This will be denoted by the triangle. Correct? This is the okay. So we can write the A symmetric difference of the B is equal to A minus B union the B minus A. correct? That we can write it. The example also you can see. Suppose if you are taking the A is equal to the 1, 2, 3, 4, 5 and the you are taking the B is other set. This has got the member 1, 3, 5, the 6, 7, 8 and 9. Correct? This many members are there. So the A minus B and the B minus A will be equal to the 9. So what will happen? The what we say, the A is a symmetry of the B. Then what we'll say, we will combine the both A union B. So it becomes the how much? It becomes the 2, 4 and the 9. Correct? So the asymmetric B means the whatever you get it out of that the common you are taking and A minus B and the B minus A and combining both will say the symmetric difference of the two sets. Correct? The last topic is last topic of this lesson is what is that? The complement of the set. Complement. Complement of the set. You are well familiar with the complement. The complement. If I ask you what is the 40-degree I am giving, I am asking the complement. What do you do it? The 180 minus the 40, you are getting the 140-degree. If I give the 60-degree, if I ask you what is the complement angle, what do you do it? 180 minus the 60, you are getting the 120-degree. Here also it is like that only. Similar to what is that? The if U be the inversor set and A is the subset. If U is the inversor set, correct? Universal set, inversor set, and U is a and A is a subset. A is the subset. A is the subset of the inversor set U. Then what is the complement of the A is the set of the all elements which are not in that. So the what will be the complement? The complement, the complement of the set A, the set A, that will be denoted by the complement of the set which will be denoted by the A dash. क्या होता है? The A dash will be whatever is a not the member, the other than what will be the member? Other than the elements of A present in the U, present in U. Inversal में जितने member है all will be there other than the element present in the A. So as I said, so whatever is the main or the bigger the set, if you are asking for the complement, whatever is left or the lacking or the less, this all will be coming into the A dash, that is called the complement. Correct? We can see the inversor set. I am taking the example which has got the 1, 2, 3 and 4 and the 5, and the other set I am taking the A which has got the 1, 2 and the 3. Correct? So there is a it is lagging because of the 4 and 5. So the A dash will be always that the complement will be the 4 and the 5. Understood? This I think you have understood. This was the end of my slide. Thank you, thank you, thank you. Please do like, subscribe, share it, and do not forget to pass the comments. Correct? Thank you, thank you, thanks a lot.